Hi, my name is Oscar Wahlberg. I'm a Director of Product Management here at Nexenta, and my goal today is kind of go through our NexentaStor solution a bit in kind of high-level architecture detail, why we consider as being software-defined and how we build up solutions with our partners. Kind of, what their components are, what the services we provide, and how we build that into an ecosystem. I was going to whiteboard that, so I'd be happy if you guys ask me questions and we can kind of take it in the direction that you want to go. That's more important that you get to ask the questions that you have, especially since I heard that you guys actually, a good few bunch of you have NexentaStor experience in the past. You might be running it at home, etc. Right? Hopefully that sounds good. Okay. So Jill talked about the difference between software-based and software-defined. We say that we're software-defined. Everything we do is defined by the software that we sell. We don't sell hardware components though. However, we need hardware to work. So this is kind of the base of the whole thing is that we start with industry standard x86 hardware. If you take our solution, you have an x86 box, and you run our software on top of that, right? You run NexentaStor. Actually, maybe we'll do this. And then we provide services out of that box. So what are the services we provide? Well, we provide unified block and file services, right? So we provide NFS. Jesus, sorry, I can't spell today. We provide NFS and iSCSI as well as fiber channel out of the box for block storage. And that's obviously file then. So, and CIFS. For
Fiber channel is also not in the community version, right?
Sorry? Fiber channel, that is correct. So that's a great point. And now you're getting into, hey, what's the difference between NexentaStor, the enterprise version, and the community edition? That's a good point. We have a community edition, which is almost identical to the enterprise version. The community edition limitations are that we only allow you to have 18 terabytes of storage behind it. We don't provide commercial support for it. And we don't have any of the plugins. The plugins namely being fiber channel and high availability solutions, right? So those are kind of the key limitations. But that's downloadable from Nexenta.com. And you can download it, you can start it, and you can run it in your own home environment, right? That's kind of the key point, right? Kind of building a...
SMB, which version of SMB?
So with the older versions of NexentaStor, it was 1. With NexentaStor 4X, it's 2.1. And we're currently working on enhancing that with the coming versions to 3.0 so that we can get better Hyper-V support, primarily. So we're working on it. So those are the main services that we provide out. We provide those from a back end that might be either direct attached disk in a single box. If you're running it in a home lab, you might have just a couple of disks attached to that in a community edition, or direct attached JBODs. So SAS direct attached JBODs, or fiber channel, right? So SAS and fiber channel backends. So that's how we grow. So we can grow this solution from a fairly small amount of terabytes to as many JBODs as you can really attach to the system in a sane way.
Oscar, you consider this a scale-out solution? Or
no, I consider, great question. I do not consider this a scale-out solution. I consider this being a scale-up solution. When we talk about scale-out, we'll get to the next, kind of the segment at the end of today, which is Nexenta Edge. That is our scale-out type solution. And we'll talk about that and why we think that's kind of the, where the future might be going.
So have you had, oh, sorry.
Now go on, Enrico.
Have you had the support for PCIe flash cards?
So we do not have PCIe flash card support today. We do definitely see customers deploy with SSDs inside of JBODs over SAS. But right now we're not running PCIe cards.
Are you planning to add support for PCIe cards? Or?
We don't have that on the immediate roadmap. We'll get to kind of how I see us working with all SSD configurations. That was kind of, I'll build to that. But right now, I don't have PCIe card support in the immediate roadmap. I think they're lower hanging fruit for where NexentaStor kind of the sweet spot is. And I think that's filling these JBODs with a reasonable amount of SSDs and creating an all-flash type array using industry standard hardware or components that you build yourself, right?
What sits in between you and the x86?
So essentially, you mean OS and
hypervisor, whatever. Yeah.
So basically, we build our appliance. So we deploy that on bare metal, or you can actually deploy it as a VSA in Xen Server and VMware. Not KVM right now. I know you asked.
No Hyper-V.
Not Hyper-V yet. So
yeah, it is coming. So
yeah, we're coming. We're working on those drivers. They're not there right now.
Question on the SAS, is it any speed of SAS, any kind of RAID controller, or just straight through, whatever?
Yeah, pretty much. What we recommend is pretty much straight through in that sense, because what we use to build the RAID is basically ZFS. Okay. So with ZFS, you're saying something, Robert?
ZFS, you will notice, right?
Yeah. Sorry, that's my heritage. I grew up speaking British English, and I've been here the last, I don't know, 2005.
Just one minor point. We don't use RAID controllers at all. We use host bus adapters. RAID controllers get in the way because unless they're transparent, they scribble on the disk in places that ZFS scribbles on the disk.
That's a fair point. We don't use the RAID component of the host bus adapters, right? So what we do though is that we grow these configurations to many JBODs. Essentially, you can grow by adding host bus adapters, adding additional JBODs. So we regularly see these grow from a small amount of terabytes to up to petabyte scale. We have customers that, actually, maybe we should dive into a bit of how we sell this to partners. What we do is that we create reference architectures with partners, such as Dell, Supermicro, Quanta, Inventec, you name it. Essentially, we work with a lot of different hardware vendors, make sure that our software works well with their hardwares, and we create what we call reference architectures. For Dell and Supermicro, for example, they have skewed up NexentaStor solutions in their system that you can buy, a smaller system, a medium system, or a large system. The Supermicro one goes up to 2 petabytes with high availability as a single SKU, right? Including all the components that you need. So basically, from a small number of terabytes up to, I would say, 1.5 petabytes, at least in the reference architectures right now. And obviously, when you get to those sizes, you need to build this out, and you basically end up adding another box with similar configuration and providing HA between them, right? Yep.
So if I was wanting to deploy in production using the Enterprise Edition, from a support perspective, do I need to go with one of your reference architectures, or could I buy HP, Supermicro, whatever I want, and then lash your software on top?
So we highly recommend going with the purebred reference architectures. We do have something that we call the Reference Architecture Plus, which is kind of more individual components that are all a part of those reference architectures. So that might be, hey, there's R720, or it's, a DL380 or whatever, right? And it's these LSI controllers. So it's not locked down to the individual components all the way through the chain, so you can kind of pick and choose a bit. But it's no longer the traditional grab bag of parts that we had in previous versions of NexentaStor, where you basically had a huge HCL that was hard for us to maintain. It was hard for customers to work with as well, because you really had to pick individual components. I understand that flexibility sometimes is really important, so we still do certifications on certain things that we don't have on the HCLs today, and we do that on on a case-by-case basis essentially.
So do you provide the development for the device drivers? Because the biggest problem is that these server vendors, they produce new servers every 12 months, probably. So you have to keep the pace with the new chipsets, with the new disks, with the new controllers. Because for what I know, I tried 6 months ago building some configuration. It's very hard to find the newer components that the server vendors are producing in newer compatibility list. So sometimes you are forced to use very old controllers from LSI instead of Dell or HP controllers or whatever.
So to some, yeah. So I hear you. To some degree, we're at the mercy of providing driver support for brand new cars, and that's something that we're continuously working on. Building new drivers. They shouldn't be very, very old, but it's also likely that if a controller is being released the last couple of months, that's probably not going to be on our HCL because we haven't seen the uptake in our customer base, or we're not that far forward developing the driver. We plan to beef up the driver support as we move along. Obviously, we need to support new chipsets as they come along. So right now,
do you provide the code to the Illumos community or not?
Yes, we provide back the most of the components, the OS, or I should say all of the OS components that we provide back to the community. The secret sauce in the sense of our management frameworks, UI and all that stuff, the stuff that's our integration and our value add on top of Illumos, that's obviously proprietary for us.
So we got a Twitter question here from Howard Marks. Is high available sync replication, is that what's being used, and how is the failover with share? Is it shared nothing, or can two servers talk to the same arrays, or how does this play out? So
that's good questions from Howard. Basically, these are mirrored configurations in the sense that both, so if you look at a HA pair, that would be a mirror configuration. They're both C disks from each side, so to speak, and you do failover based on that, right? We also have asynchronous replication to a DR site, but that is really what amounts, and this configuration again, NexentaStor x86, this could be a completely different physical type of configuration. This could be high performance nodes, and this could be a bit slower and cheaper nodes.
So let me try to understand. In a mirrored configuration, then both servers are talking to the same JBODs.
Yes, they're both talking to the same JBODs. Okay. So you basically mirror between the JBODs.
Right.
No, I'm sorry. So your picture doesn't show it as the same two. They're not talking to the. Okay.
Oh, that's
right.
Much
Sorry.
better. Much.
Okay.
But what about the cache and all that stuff? So there's data in cache that hasn't been flushed to the disk. If a power failure occurs, what happens to that data?
So we have something that we want. So there are multiple parts to that, right? And Robert is actually one really good guy to explain that if we want to go in super detail. But basically, what we do is like we have, you have a RAM cache at the top, obviously. We have what we call an L2 ARC, which for those of you guys that are familiar with ZFS, for example, that's essentially the layer 2 cache. And you have disks at the bottom. Now, for synchronous writes, we also use something that we call Zeus RAM, which is basically a way for us to quickly store synchronous writes as they come in. And that is basically a DRAM device that's SSD backed, right? So that allows us to quickly return on sync writes as well. Now, this is all, if we look at this, how it looks in the configuration, you might have SSDs on these sides, right, for the L2 ARC.
And that's when the transactions
right.
And the L2 ARC, I should say, is volatile in that sense, right? That's a cache, a pure cache.
And is all this stuff taken care of in your software, or are you taking advantage of things like in the LSI HPAs that know about dual JBODs, dual servers and all that?
So the only thing that we use from the HPAs is essentially the ability to do dual paths. In that sense, so we're using, hey, I can get to that JBOD, I can get to that JBOD. Then we use Illumos or multipathing in Illumos to make sure that we have redundancy across that. And on top of that, the RAID portion is done through ZFS or ZFS if we want. I'm mixing and matching here, UK. So essentially, we're not relying on RAID cards to do RAID. They're just providing transport to the disk.
Well, my question is, some of the LSI cards also do failover. They understand SAS on two different systems talking to the same disks, and there's some failover capabilities in the hardware.
So we're not using that right now. Okay. So yes, so back to DR. So this is basically asynchronous periodic replication based on snapshots. And you can take, as many snapshots as you want, and they can be, if you don't have a huge change rate, you can have a pretty small time frame, and then you just sync it over. This system could be configured completely differently. It could be on, you know, bigger and slower drives. Doesn't need to perform as well as a DR system. We have customers that are running these at satellite type offices, or, you know, in the core data center, and replicating to a distance to a DR site where they're centralizing resources.
So the DR is on the send receive functionality of ZFS? Or? Okay.
Yes, that's a part of it. There's also, you know, clear integration into how we're doing things that's unique to NexentaStor. But the base functionality part of that is send receive.
In the HA config, how similar do the two systems have to be?
I would say that they should be similar.
Okay,
you know, they should be identical.
Yeah.
So technically, you can get it to work with different type of systems. Reality is, and I come from a high availability type background. I worked with clusters for the last 15 years. If you have cluster pairs, make them identical. It's going to be less headaches for you. It's just, you know, common sense, essentially, right? So.
And you mentioned Zeus RAM. So in an HA configuration, you're required to have SSD for Zeus RAM? Is that?
Actually, the tech.
Yeah. Come on. Get in picture.
Let me just clarify a couple of the technical details. First of all, the common device for handling write operations is called the ZFS intention log, the ZIL.
ZIL, yes.
ZIL, one instance of that is Zeus RAM. Actually, any type of drive, whether it's a spinning disk or a RAM disk or a flash disk, can be used for the ZIL implementation. The only requirement is that that ZIL device must sit between the two systems so that it has common paths to both systems. What we do is we write into the ZIL device what we intend to write to the Z pool, the main pool of drives. If the system fails before those writes complete, when the system failover occurs, the secondary system first goes to the ZIL, completes the operations that we're intending to complete, and then brings up the file system and exports it to the external world. In this way, ZFS guarantees it's always 100% consistent. It never requires an FSCK to rebuild the file system.
When you say the ZIL lives in between the two devices, just explain what that looks like.
Okay, in terms of our HA configuration, what actually happens is the two systems have common access to all the drives, both for the main pool and for the ZIL, so that you have to have a SAS channel from system A to the ZIL device and from system B to the ZIL device, so that during the failover process, which is about a 15-second process, 12 of the 15 seconds is SCSI fencing to shoot the other guy in the head, make sure he's dead and can't talk to the drives, and then the other system takes over and has complete control to bring everything up in a sane state.
I'm sorry, I just want it to be clear. So you would have a drive in each of the JBODs that on the picture there, or you'd have a shared drive?
You have a shared drive. In fact, all of these are organized as shared drives in the Z pool.
Right.
You can organize the Z pool so that one system is primary for one set of drives, and the other system can be primary for a different set of drives, so that you don't run into SCSI fencing problems. And that's the way in which it can be active in that sense. But from each side, it's active-passive.
Yeah.
But the ZIL log device is always going to be active from both devices?
The ZIL log device is actually active-passive. So you'd have, if you do two different actives, you have to have two separate ZIL devices. Okay, one for each one is a primary.
Passive, always active-passive.
Right. Okay.
And the Z devices need to be mirrored.
I'm sorry, say that again?
The Z devices has to be mirrored. No?
The ZIL device
should be mirrored.
Does not have to be mirrored.
As long as it's shared.
As long as it's a shared device. Because either system has access. And I think we're running past our time if I'm chewing it out with
Yeah, so the only thing, closing off, the only thing that I wanted to talk about was really that where we're going with this. Right now, we saw most of the deployments and smaller system growing to larger. What we're also seeing is some of our key customers that have kind of been running NexentaStor in larger deployments for a long time. They've started migrating to actually running NexentaStor on all flash type backends. So that's something that Jill mentioned earlier on, that the 4.1 release that we're coming out with will have a reference architecture that is all SSD backend. And that's really, the ability, it kind of opens the ability to use, whatever server vendor you want to use, be it Dell, Supermicro, HP, or whatever, with their chassis and the SSDs that make it available to run all flash type configurations. So that's something that we're hoping will actually be changing a bit of the flash market, that you can actually get all flash performance, maybe not at the pinnacle of all the performance if you look at high-end type solutions, but 80% of the way for 50% or less of the cost. That's where we're aiming.
Maybe I missed this. Did you talk about how many, or did Jill talk about how many customers you have, how many using the Enterprise Edition, and how many petabytes you've got out there?
So I don't have the split community to enterprise. In total, I think we have, well, sorry. Yeah.
Give up my mic.
You need to turn on. Yeah.
So it's about 5,500 customers, and the split on that is about half and half between community and enterprise. And if I split the enterprise side again, it's about half sort of what you think are classic enterprise customers, and then the other half about small and medium business.
And the license is on a customer basis, or is it on a server basis, or?
Perpetual capacity.
Oh, per capacity, okay.
Per capacity, right? And you asked how much kind of real estate or storage estate we had out there. Close to an exabyte, I'd say between 800 and 900 petabytes at least. It's a bit hard for us to judge the community edition, of course, but when we look at enterprise customers, so it's a pretty large amount.
What, so nearly an exabyte on the Enterprise Edition?
Not entirely on enterprise, but we have customers.
So nearly an exabyte in total?
In total, yeah.
Okay.
So we have customers, we have enterprise customers with more than 100 petabytes on the floor. So.
In total, or you have an enterprise customer with more than 100 petabytes?
One single customer with more than 100 petabytes on the floor. We have a couple of really large customers.
Public cloud company.
Yes.
Wow.